Welcome back, reinforcement learning. This session I explained navigating with the Q learning topic with the building the network. Navigating with the Q learning. In this topic, I explain the subtopic is building the network. Okay, in Q learning, we are learn the agent learn using Q function. Okay, to get the maximum cumulative rewards. Okay, this is the main aim of the Q learning. The Q learning Q function is the central concept in Q learning. The Q function is implemented using neural network. In this topic how to implement the Q function using neural network. Okay, in this example, we are using grid world example to implement the Q function of the grid world game using neural network. Okay, this grid world game contains the 4-dimensional 4x4 in a game, 4x4 grid world game. It contains the 4x4. It has the 4 objects: the agent, wall, pit, and goal. Okay, the main aim is the agent must navigate along the shortest path to reach the goal tile without touching the pits or walls. That is the main aim in this grid world game example. Okay, the overview of the we are main focus in this session is to implement the Q function with the neural network. The neural network in this grid world example, the overview of the neural network architecture for this grid world game is the neural network contains the 3 layers: the input layer, hidden layer, and output layer. Here this grid world game contains the 4x4 the 4 grids, 4x4 grids. So it has the input layer contains the 4 into 4 into 4 tensor. So the flattened values are the 4 into 4 into 4 is 64. So it has the one dimensional, the flattened length of the one dimensional tensor is 64. This is the input layer. Number of neurons in input layer is 64. Hidden layer contains, we are taking hidden layer 150 neurons. In output layer, the output layer in this grid world game, the output layer is actions. How many possible actions this grid world game is: move up or move down or move left or move right. Okay, these are the actions. So the output layer contains the 4 neurons. The output layer consists of 4 neurons. These 4 neurons corresponding the possible actions in this game. What are the possible actions? Up, down, left and right. So this neural network architecture is as the input layer consists of 64 neurons, hidden layer consists of 150 neurons, output layer consists of 4 neurons. These 4 neurons represent the possible actions of this game. Here input game receives the game state. This game state is represented with the tensor 4 into 4 into 4 tensor. So it has the flattened tensor is 64. It is the input to the this is the indicate the game state. This is the input to the neural network input layer. So this is the neural network input layer receive the 64 tensor values from the that represent the game state, and it gives the 4 output values that represent the 4 possible actions of this game. So here the general original Q function, it has a state and action. The state and action, it returns the Q value. It returns the Q value. Here DeepMind modified Q function. The Q function is this Q function is implemented with the neural network. It receives the input is a state. The state of the game state is the input to the neural network. That is this neural network is implement the Q function. This Q function is implemented with the neural network. It returns the possible action Q values, possible action Q values. Here we have the 4 possible action, their corresponding Q values. This is the the Q function is implemented with the neural network. This is the ordinary Q function. This is the input, the state and the action. It returns the Q values. If we are implement the Q function with neural network, it receives the state is the input and it returns the Q values for the all possible actions. After that, it returns the all possible q values of all possible actions. We are find the best q value. How to find the best q value? We are applying the different methods. In this example, we apply the epsilon 1 minus epsilon greedy approach. Here the state q function, it reads the 4 q values. These 4 q values, we find the best q value by using epsilon 1 minus epsilon. In 1 minus epsilon, which is the epsilon smallest value for random action selection, and 1 minus epsilon we are using to select the best action. If you are taking epsilon is 0.1, we are using 0.1 times, we are apply the random action. Remaining 1 minus epsilon 0.9 times, we are find the best action. Here implementation, this is the architecture of the neural network for the grid world game to implement the Q function for that game. Here the steps, the programming steps to implement the building the neural network for the grid world game Q function. The first one is implementation setup. Implementation steps is to first one, import the necessary libraries. We need the neural networks. So first we are implementing torch, PyTorch. So import torch. Next import torch.nn for the neural networks, and import the torch optimization method as optim. So in first one we are implementing the libraries nn, torch and optimizer. Next one is we define the neural network class. This class define the layers and forward pass. So here the neural network class name is Q network. Q network, we are implementing the Q function, that's why the Q function, Q network, the network for Q function. This function, this class contains the define the layers and forward pass. These layers contain the two layer input layer nn dot linear 64 150, 64 inputs 150 outputs. This is the input layer. Next self dot hidden layer is nn dot linear 150 and 4. The 4 is the output layers. Output layer options, 4 possible actions. Next in forward pass we are mentioned the activation functions. Yes, ReLU is the activation function, and output layer hidden layer is the output layer, and finally we return the X. So they define the neural network class. You are mentioned the layers, and we mentioned the forward pass consist of output layer and activation functions. And next we instantiate the network class object. The Q underscore network is the object of the Q network class. And next we define the loss function and optimizer. Okay, criteria is equal to nn dot mean square error. Loss function is we are using mean square error, and optimizer is we are using Adam optimizer with learning rate 0.001 in this example. So this is the after we build the network, we train the model. During the training we have followed the steps. Is the first one is feeding the game state is input to the network, and we calculate the Q values and compute the loss function based on the expected values, and in order to reduce the loss we perform the backward propagation to update the network weights. So here building the network, building the neural network to implement the Q function of the grid world game. Okay, this is the basic, this is the fundamental concept in reinforcement learning, in specifically in the Q learning concept to understand the reinforcement algorithms. Thank you.